The purpose of this video is to explore two more methods of triangle congruence, known as angle-angle side and hypotenuse leg. Now, angle-angle side says that if two angles in the non-included side of one triangle are congruent to two angles in the non-included side of a second triangle, then the two triangles must then be congruent. Probably the most important word in this statement is the word non-included. And we're going to talk for just a little bit about what that means. And looking at the pictures, you have angle A congruent to angle A prime. You have angle C congruent to angle C prime. Now, the included side would be the side that connects angle A and C, or in other words, side AC, and in this triangle, side AC prime. That would be an example of angle side angle. This is not the situation, not the scenario we have going on here, but rather we have a side that's attached to angle A and A prime, but not attached to angles C and C prime. And that's what makes this guy the non-included side. And if you look at the name, this side touches one of the angles, but not the second. Just like side AB is part of angle A, but not part of angle C. Likewise, side A prime B prime is part of angle A prime, but really doesn't have a whole lot to do with angle C prime. So again, just to reiterate the important difference, angle-angle side has a pair of sides that's attached to or connected to one of the angles, but not to both, whereas angle side angle has a pair of sides that connects or joins both of the two angles. So that's angle-angle side. The second new method of proving triangles congruent is called HL. And this says if the hypotenuse in one leg of a right triangle are congruent to the hypotenuse in second leg of a second right triangle, then the two right triangles are congruent. And this is really important that we have right triangles in order to use this method of proof. If the triangles aren't right triangles, then this doesn't work. So when looking at the picture or the diagram here, it's important to look for the right triangles. So note the right angles, making those triangles right triangles. In the picture, you've got a pair of hypotenuses, which are represented by segment AB and segment BC. And you've also got a pair of legs represented by the shared side in each triangle, BD. All right, now, we have previously learned three methods of proof: side, 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 angle, and angle, side, angle. And we have learned today two more to add to those. Those are the only 5 methods of proving triangles congruent that exist out there in the whole wide world. This is true for high school, for college, post-college. If you want to prove triangles congruent, these are the only 5 that work, and I can pretty safely say that will ever work. So in trying to prove triangles congruent, we're going to look for one of these 5 scenarios. So down at the bottom of the page, can we tell from the information that's been given that the two triangles are congruent? If so, circle all your reasons, and then they give us this little note. Some triangles may be able to prove congruent by more than one method. So if so, circle all that apply. So in looking at the picture, the first thing I'm going to do in each and every case is I'm going to look at the diagram, look at the picture for shared sides, and look for vertical angles. In this first picture, I notice a pair of shared sides. There aren't any vertical angles, so I'm okay to go ahead and start my analysis. So I think the easiest way to do this is just to go look through and say, is this 3 pairs of sides in one triangle congruent to 3 pairs of sides in the second? No. Is this an example of side, angle, side? Well, we've got the pair of purple sides that are congruent in both. We've got the pair of green sides that are congruent in both. We've got the yellow angles that connect the purple with the green. I like side, angle, side for this. The third choice, angle, side, angle. Well, we only have one pair of congruent angles. Angle, side, angle needs 2 pairs of congruent angles. Likewise, angle, angle, side needs 2 pairs of congruent angles, so that one won't work. And the last one, HL, in order to use this one, we need right triangles. And though it looks from the diagram like those angles might be right angles, we cannot assume that from the diagram, and therefore we have to reject HL. So I'm looking side, angle, side for the first one. Just on a quick note, there are some additional pairs of congruent angles in this picture due to the fact that the triangle is isosceles. I don't want to talk about those any further, any deeper, until we get into the unit which involves isosceles triangles. All right, I'm going to go ahead now, flip up to the top of page 31. I'm going to look at the diagram for vertical angles. There are none. Examine the diagram for shared sides. There is a pair right up the middle there. And now that I've finished marking my diagram, I'm all set to go ahead and begin my analysis. So choice 1, 3 pairs of sides. There are only 2. Choice 2, side, angle, side. Well, if this angle here is a right angle, this guy here's got to be a right angle as well. So I like side, angle, side. Choice 3, angle, side, angle. Well, this one would require 2 pairs of congruent angles. We only have 1, so that doesn't work. Likewise, angle, angle, side would require 2 pairs of congruent angles. We only have 1. And last one, HL, would require a pair of right triangles, which we do have, a pair of congruent hypotenuses. Well, the hypotenuses in this picture are going to be the segments that I just color-coded red, and we don't know whether they're congruent or not, and therefore we have to reject HL as a possible method. All right, number 3. No vertical angles. The pair of shared sides is already marked congruent, so I'm off and on my way. Not 3 pairs of sides. We do have 2 pairs of sides and a pair of angles, but we don't have the angle that attaches or touches to both sides, so reject side, angle, side. Angle, side, angle we have to reject because we only have 1 pair of congruent angles. Angle, angle, side we have to reject because we only have 1 pair of congruent angles. And the last one is hypotenuse leg. So I'm going to look for a pair of right triangles, which we do have due to the fact that these angles are right angles. Pair of congruent hypotenuses, which are represented by the red line segments, and a pair of congruent legs represented by the blue line segments. So that's what HL is going to look like for you in a picture. All right, number 4. This is probably going to be the last one that we tackle together here. I'm going to start by, again, analyzing the diagram, looking for vertical angles. There's a pair there and there. I'm going to look for shared sides. There aren't any. So now I'm all set to go ahead and begin my analysis. But I think before I do that, I'm going to take a look at the 2 triangles. I've got a red triangle here, and I've got a purple triangle here. I know that the blue angles in each are congruent. I know that the right angles in each are congruent. Because all 3 of the angles in each triangle must sum up to 180, if I know 2 out of the 3 angles are congruent, I also know the 3rd pair of angles are congruent. So this is a theorem that you can use in your proof and that you should always look for whenever you're dealing with triangles. If 2 angles in one triangle, and you should be writing this down on your paper as I'm writing it down, are congruent to 2 angles in a second triangle, the 3rd angles must also be congruent. And you can write that as a reason in any proof or any argument that you want to use from this point forward. So in looking at number 4, I'm going to now go through and analyze and decide which of these ways may or may not be used to prove these triangles congruent. Side, side, side is out because I don't have 3 pairs of sides. Side, angle, side is going to be out because I only have 1 pair of congruent sides, and in order to use side, angle, side, I'd have to have 2 pairs of congruent sides. Angle, side, angle will work if I look at the blue angle, the pair of congruent sides, and the right angle. So I like that one. Angle, angle, side will work if I look at the green angle, the right angle, and the pair of congruent sides. HL will not work because I don't have a pair of congruent hypotenuses. So there's a nice example of a pair of triangles that can be proved congruent by 2 different methods. I'm going to have you finish numbers 5 through 12 for when you come into class tomorrow. And we'll see how you did with those and if you need any more practice on them or if you're in a good place. As always, thank you for taking time to watch the video, for the gift of your time. I hope I've made it worthwhile and that you've learned something from it. And again, my thanks.